This module will be covering the concepts related to kinematics of cyclic motion. So a lot of tasks we do in human movement are cyclic in nature, so essentially we see them as the same task repeated over and over again. So a prime example of that is walking, or as we refer to in biomechanics, gait. And you can see it broken down into different phases and points there. And we'll talk about the gait cycle more later this semester, as well as in Exercise Science 220. But I just want to cover in this module the kinematic concepts related to breaking down any particular cycle. So this is not going to be specific necessarily to walking. The same principles can apply to running, to swimming, to cycling, and a number of other cyclic movements that you may be able to think of. So when we consider these cyclic motions from a biomechanical perspective, the first thing we ask ourselves is what's most important about these cyclic actions. And typically, because these cyclic actions we tend to be covering ground, the most important aspect is the average velocity of each cycle, because it's the person with the highest velocity in any of these cyclic tasks which is going to cover a certain amount of ground in the lowest amount of time. So cyclic velocity, and if we think about the influences or the direct influences of cyclic velocity, so how fast we're going with each of those cycles, the two things that really directly influence that is the length of each cycle, so how far each step is in the walking, for example, and the frequency, so how many steps we can do in a certain period of time. So we can see that relationship described by this formula here. So cycle velocity is your cycle length multiplied by your cycle frequency. So a really simple formula demonstrating how cycle length and frequency both influence velocity in equal degrees. Now when we're doing calculations, it helps us to have that formula, and we can rearrange it in different ways to be able to calculate our cycle length and our cycle frequency. So same formula rearranged in different ways. You might also see cycle time, or we might also be interested in certain examples in the time of a particular cycle, which is just 1 divided by cycle frequency. So if we go to an example now and see this one here where we might be interested in what the walking velocity of our participant is when we know that their step length is 0.8 meters, so that's the cycle is their step in this case, and the frequency of steps is 1.7 steps per second. So the velocity calculation is simply just the length multiplied by the frequency, 0.8 multiplied by 1.7, and her walking velocity would be 1.36 meters per second. So if we take another example here, a different activity, swimming, same calculations, we're just talking about swim stroke instead of steps. And so if we get given the stroke time of 0.8 meters and the stroke velocity of 1.5 meters, we might be interested in the stroke length. And we can just take a rearrangement of some of the formulas I gave you previously to understand that cycle length is cycle velocity times cycle time. So if the stroke length is going to be 1.5 times 0.8, and therefore it's going to be 1.2 meters. So there are some great resources for the other broader physics concepts that we've covered in the linear kinematics module as a whole. Unfortunately, there's not a great deal I could find out there on cyclic motion other than the textbooks that we recommend in your unit outline. If you find any others, then please let us know through the forum.